Dr. Kyle. Thank you very much, students, for our report today. I do apologize about the Zoom link that wasn't updated correctly on the daily agenda. I have our technology team fix up our future ones so we could be okay on that going forward. The presenter today will be Dr. Kyle. Thank you so much, Dr. Kyle.
Hi, Elmer. Hi, everyone. Are you guys able to see my screen now? This HTML file. Okay, great. Yeah. So today I'm going to walk you through some of the very basic techniques of R programming and basically some of the very popular commands that you can use when you write some R commands or when you write an R script. And also I'm going to introduce you the basic data types that you have in R that will enable you to make all kinds of statistical or mathematical operations on the data types. And then I will also introduce how do we read data from certain files and how do we make operations on those data files. Okay, so to get started, I trust that everybody has already downloaded and installed R, right? Yeah, and you can also download and install R Studio. So R Studio is a more user-friendly interface for R programming, and you can make all kinds of more fancy visualizations and also make tutorials within R Studio, just like this whole tutorial that I have made today. So this whole document was made from our tutorial using R Markdown. I think that Dr. Zhang might have mentioned R Markdown yesterday. So as you could see from here, so this whole document was made, is called a R Markdown file. And here you can see that you actually have different colors of these words or characters, and you also have different fields of these words. So these are the instructions, and these are the R programs that are separated from the rest of the tutorials or the introductions in here. And also here, so you can see very clear blocks using this R Markdown for you to differentiate between what are the extra things that you add to this document to help you explain the things that you want to say. And then there's also the commands that you can copy and paste into your R console or an R Studio console, so that it can get up running in there. So this is some of the good things about using R Studio, and there's definitely more features that you can use. For example, debugging, documentation, and visualization in relatively simpler steps. Okay. So while I'm talking in here, I hope that you guys can also open your R console so we can actually work out all these R commands all together. Okay. So for example, every programmer starts with a print hello world command in your computer. So you can, so this is pretty much the very first command that you can have. So you print this in your R console. So this is my, so this is my R console in here. And I don't know if you guys have installed R or R Studios together. So, but for example, if I type in print. And it will just show up in here. Okay, and also, um, um, so a very powerful feature of R is that it is a free software, and everybody in the community tries to strengthen this software by contributing to it. So when R was first developed, it had some very basic functions into it. For example, adding um, divisions or some of the basic matrix or other data types operations that are built into R in the very first beginning. But later on, as people use R more frequently, and as people that as our users started to emerge from all kinds of different research fields, there are more advanced techniques that you can program using R. So that's how people, for example, today I built a new software and I wanted this one to be able to benefit the whole community. Then I will just make an R package that is compiled based upon the programs that I have made. And then I can share this package through to the whole R users community by uploading it or by publishing it with CRAN. So CRAN. CRAN is the community for the whole R learning um, communities. So so um, needless to say, the packages in R are the most powerful tools that you can use. So many times when you need something, um, you might want to check if there are already R packages out there that you can already use so that you don't actually have to write your own programs to save your time. And many times, these R packages are actually compiled using more powerful languages, for example, C or C++ or other types of languages that can even facilitate the whole computational efficiency. So, so um, so so taking it back to the packages, if we wanted to install a package, then we just use this command called install packages. So this will help us install a package called a data.table. Okay, and the next time when we want to use this package, we can just let's try it here. So I have already have this data.table package installed in my R, and if you don't have it, then you can install these packages in here in case that you might use it. And you can use this command, install packages, to see all the packages that you have installed in your R working space. Okay, so I have installed a lot of the R packages because many times I just want to try out different algorithms in my own research. So there are some things that you can get help. Some ways for you to get help on certain packages. For example, if you wanted to see what does the package called a base do, what does this package do, and then it will pop out this page to this documentation page for you to see what this package is about, the authors, the version of this package, and the built-in functions within these packages. So this is a very, very basic package that is built in R. And certainly you can update a package to a newer version, or you can remove a package or you can remove a package from your working space by typing this command in your R. And here, if you want to use this package just like what I did, then you just type in library and the package name of it. And you can also find out the versions of this package. So the importance of the versions of the package is that definitely the contributors of a package they do not just publish their package and just let it go, but instead they will periodically update the package. And if a package in Quran, the R community, the R users community, that if a package within the Quran has not been updated for a long while, it will become an orphan package. And I think Quran has a certain way to detect these obsolete packages and yeah. So people, in order to increase the use or popularity of your package, you wanted to you wanted to regularly update your package or debugging your package, because the package might not be compatible in every computer. Okay, so this is some of the basics about package installing and the functionalities of the package. It is simply some programs that other people have written. So to make it a whole to make it a to package into a whole program. So when you wanted to use this program, you can simply type a very simple command to use that program instead of writing a whole function out of it. And within R or within RStudio, some of the shortcuts are very useful. So for example, when I so when I when I wanted to type in this command called a library, I can just type in lib and use the tab command so that it will help me complete this function called a library. Um, or sometimes if I have a variable within my working space and I just type the first two letters, and it will help if I click the tab command, it will help me complete my command. It will help me complete this variable name. So this will help you. Sometimes you don't know, you don't remember the exact names of a function or a variable or any kinds of object in your R. So you can use this tab command to complete or to help you to remind you of what kind of objects that are in your working space, or it will pop out some of the possible commands that you might be using, so you can just choose one of them. Okay. And if I wanted to go back to my previous command, for example, I have already I wanted to get more help on this base package, and I have done this 3 commands before. I can use my up arrow on my computer to go back to this command, and I can use my down arrow to go down to more recent commands that I have used. So this up arrow can help me go back to anything that I have used in this session. Okay. So these are 2 very popular commands when you are using R programming, the tab command and also the up and down arrow. So there are other shortcuts that are used, but I think these are the 2 that I use and I personally use the most. Okay. And here are some of the very simple functions that you can call. So the list function is to list every R objects that is in your current environment. For example, if I type in ls in here, so I can see, oh, I have a variable called a and another variable called a and a third variable called a dat. So I just want to make sure that everybody is able to follow these commands, and you were able to actually type in these commands in your own computer, right? Okay, so if you have any questions, please type that. Could you please you can type that in the chat box. So so Peng Tao or I, if I see I can answer the question. So yeah, actually Laura asked the question, so if we can poll the students to find out how many have downloaded R console. So so how many students have used have downloaded it and installed R console for now. If you have done that, can you raise your hand, please? Okay, great. Maybe I saw a lot of you guys have downloaded and installed R. So anybody who has not installed R so far yet, can you raise your hand? Can you please raise up your hand? Okay. Okay, I saw 3 students who have not yet installed R in their computer. So is there any difficulties? Um, did you have any difficulties, or you just haven't had the time to do that yet? Because I think it's very necessary for us to be able to do that. Okay. Um, yes, our studio is fine. Um, you don't need the R Studio server. The R Studio desktop is okay. So yeah, I think I can send. I'm so. Um, Peng Tao, can you? I can. I want to send you this document to you so that you can maybe you can create a Google link so people can actually access this whole R Markdown file, so they will be able to download and install R or download and install R Studio. It is just a simple click in here. Okay, Peng Tao.
Okay.
Yeah, maybe you can create a Google link or so that um, and then you post that link to the chat box so people can click and access this file. Okay. Okay. So I think for those of you who have not had a R installed in your computer, don't worry about it. This tutorial is quite comprehensive. So the 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 whole the basic idea for this tutorial is to so this tutorial is pretty much self-sufficient. So if you can so the goal is for you to be able to run through all this code without any problems. So everything within the box are R commands that you can copy and paste into your R console. Okay, so and every command that starts with a with a command, so these are command symbol. So when you put such a symbol behind in front of a in front of a line of your command, it will be ignored by R. So for example, if I say print hello world, it will print this in here. But if I put this symbol in front of it, it will automatically ignore what I have typed in R. Okay, so this symbol is meant to separate from something like a, so this symbol serves the purpose of explaining this code to yourself or to the other users. So as you can see from here, so adding this symbol, it will tell me, oh, what does this command do? So, oh, it actually, this is helping me explain this command is actually doing the package installation of data.table. Okay, so so you can okay, yeah. So everybody, if you have questions, please don't message me privately because I may not be able to answer your questions immediately. Please please make your message public, maybe, or to Peng Tao. Um, so um, so you can, after you have after you access this document, or after you have this one after this class, then you should be able to copy and paste all these commands into the R console and then see the results. Okay, so so far we have only discussed about some of the very, very basic usage of R, including the R packages, and this is and some of the very simple calls that you can use. So what is the current directory, or how do you set up your working directory? For example, you have many different you have many different folders in your computer. And for this project, you wanted to work in project folder 1, and for another project, you want to be able to work in project folder 2, and you don't want to mess up these different folders. So by using this command, set wd, set working directory, it will help you navigate to different directories or different folders. So the data from different projects will not mess up with each other. For example, this get WD is called getting working directories. Okay, getting work directories, and this one is telling me, okay, I'm in this directory of my computer, and it's called a basic R. Okay, so, and if I wanted to if I wanted to use if I wanted to set my working directory to a different directory, then I can just type in whatever whatever directory that I have, and now my working directory has been changed from this basic R to just errands. Okay. So there's a tiny difference between the path that you type in Mac and you type in your PC. I think in Mac you do yeah, I think in Mac you use a left slash, and you use a forward slash, and in PC you use a backslash. Okay, so this is the difference. This is the difference between when you set up the working directories in a Mac or a PC. Okay. So of course, when you type in this in your computer, you need to change this. You need to change your name to your name. What is the username of your computer, or you can simply say setting working directories to desktop. Okay, so this is the working directories that I am using. So this is the output that I am getting in here. Okay. Um, so so this is the output that I'm getting from I typed it. So which is one of the features of using this R Markdown file. I can display the command that I have used in my R console, and at the same time I can see the outputs from the command that I have just used. Okay, so this is the output from here. So when you type in the commands, please you don't have to type in this output from here because it will automatically display in your computer. Okay. Yeah. Let me check. Yeah, I just saw that people having um, difficulties installing the R Studio. So like Pengtao suggested, you should download and install R first before R Studio. And I think that for different versions of the R, um, there are differences, and sometimes you may want to install this version, and sometimes you may want to install that version. Um, the very basic, those very basic functions will be quite similar to from one version to another, but the the difference is that some of the packages or some of the newer packages are only available for newer versions of the R. So only newer versions of the R can support the newer versions of the packages. And for some of the older packages, they may not have been tested on the newer version of the R yet. So when you install the older packages, it may say, okay, this package is not available for the current version of the R. And sometimes when you publish a package on CRAN, when you publish the package on CRAN, it will ask you what kind of R versions does support your package. So that is the difference for you to that is the difference for you to consider when you install different versions of the R. Yeah. So Pengtao, have you sent out this tutorial to the students yet? Okay, not yet. Okay. Please, yeah. But that's okay. So, like I said, this file is pretty. You can try to type this command in your and try it on your own computer after this class. Okay, so and so after some of the basic introductions of R. So now we come to introduce the data types in R. So this is the most important part of R programming. So we know that when we perform certain operations, there are symbolic calculations, and there are just there are non-symbolic calculations that you have numbers. But for symbolic calculations, it is so R is not very good. Yes, I saw that Wen Hui has a question and raised your hand. Do you have a question, Wen Hui? Okay, if not, I'll just keep going. So, for symbolic calculations, some students might have heard of calculus. So you want to calculate the derivatives or of a function. So that is and you have and you deal with A, B, C. These are symbols. Okay, so those are called symbolic calculations, and there are also more of the numeric calculations that R is better at. So for symbolic calculations, I know R does not have a very good power in dealing with that. And like if you want to calculate the derivative of function, then there are functions that can help you do that. But R is not the most powerful tool that you can rely on. And R is better at dealing with the numerical calculations. So you have the very basic data types are called atomic types. You have logical values. For example, you have a variable that can take values only between true or false. And you also have integer variables that can only take values from integers -1, 0, 23, something like that. And you also have numeric variables. It can be an integer or a non-integer or just a real number like a 2.2, 2.12, or a negative value -4, a positive integer of 23, or a complex number. I'm not sure if you guys have learned about a complex number or not. It has a real part and it also has an image part. Okay, and this little I here is denotes the complex part, the image part. And you also have characters. For example, when I print a hello world in here, I am printing I'm printing a character, a string of characters. But if I print a 2, I am printing a numeric value in here. Okay, so this is the, sorry, I typed a hello wrong. um, but these are the different characters, and the so you know, the reason that we should differentiate between these different data types is for the purpose of space, like space allocation. Because one might say, oh, if you already have a numeric, why do you still need integers? Because integers are numerics too. But the reason that we sorry, I think I lost the internet connection for a little bit. So where should I start?
We lost you just right when you were discussing the need for integers and being numeric.
Okay, great, thank you. Yeah, so so an integer might require a much smaller memory space to store the number, but a numeric will require a larger memory space to store the number. So that is why we sometimes specify what kind of data types this number is, even though this integer is only a subset of the numeric. Okay, so when you are dealing with numbers that are all integers, you might want to specify that they are all integers. But when you know that there are some numbers that are non-integers, so you might want to include it. You might want to use numeric. But I think this is a for myself. Sometimes I do not intentionally remind myself of these differences because I'm not a very good programmer. But when you wanted to write a very highly computationally efficient and the memory saving or memory efficient programs, you might want to remind yourself of the different data types and how do you want to store them. Okay. And after you have this very basic atomic data types, then you can create all kinds of data types with the atomic types. So like this figure is showing in here, you can create a vector that has multiple values in it. So for example, this is a vector of 3 values, and you need to know that everything in the same vector should be of the same types. Okay. So for example, the first element, if it is a numeric, then everything, if this is a numeric vector, everything in this vector will be numeric vectors. And if it is not, it will be coerced to become of the same character type or the same atomic types. Okay, so they need to be all characters or all numeric values or all logical values. Okay, and for matrix, it has the same it is the same thing as in vector, that everything needs to be of the same data ethnic types, whether this is a character matrix or a numeric matrix. Okay. Difference between matrix and a vector is that a matrix can have a matrix is a is consisting of multiple vectors. Okay, so this matrix has a 3 row vectors, 1, 2, 3, and or you can say it has a 3 column vectors, 1, 2, 3 in here. Okay. So the array here, or sometimes we call it a tensor here, is that it has more dimensions than a matrix. Okay. So if you have multiple vectors of the same length and of the same ethnic type, then you can make a matrix out of it. And when you have a multiple matrix, you can combine the matrix into an array to make an array. Okay. So this really depends on the complexity of your data types. So yeah. So if it is I'm yeah.
Oh, this is C. You're here. Okay.
Okay. So you can store depending on the complexity of your data. If you can store it with a vector, then that's okay. But if you have more complex, for example, if you wanna store the grades of different students, then you might wanna or if you just wanna store the grades of a student, then a vector should be fine. This vector will consist of the grades of math and other subjects. And if you want to store the grades of different subjects for different students, then now you have 2 dimensions. First dimension is for students, and second dimension is for different subjects. And then if you also want to store this for if you also want to store this for multiple, like you have midterm and you have finals and you also have some quiz for different subjects, for different and also for different students, then you will have 3 dimensions, right? So what time is that, a final or is that a midterm, and also which students, and then also which subject. So then you will need an array to store all these data. Okay, and then so the problem with the matrix and the array and the vector is that they can only store data of the same type. The data frame is a very, very powerful data type that can store more heterogeneous types of data or vectors. For example, this, so for example, if you wanna, compare the, if you want to compare the I think the different functionalities of cars for different models, and you definitely have different features to describe it, right? Or if you want to describe the different the profiles of different patient subjects, then you might want to memorize what is their gender and what is their BMI and what is their height. So for gender, it is a character or a categorical variable, but for their BMI or weight and height, they are numerical variables. So you cannot store these data types with a matrix, but with the data frame, it is more convenient for you to store these different heterogeneous data types into it. And also for the data frame, you can only store for you can think of each column as one feature and each row as a different different subjects or different participants in the data recording. Yeah, okay. I saw that somebody has posted. I saw that Laura has posted the document to the chat box. If you need to access it, please do that. So then you will need everything. So everybody needs to be observed for the same for the same set of features. But what if I wanted to do what if I just wanted to memorize different things quite differently? For example, in terms of for example, if I have observed 3 patients, in terms of their gender, I have a vector, and in terms of the weight, height, and BMI, I have another vector. And in terms of their other characters, I might need a matrix to describe that feature. Okay. So then you can actually concatenate all different data types of even different dimensions into a list. So pretty much everything you can just throw it into a list, and it will be compatible, because that is the power of the list. Okay, so it does not even have to be of the same dimension. Okay, so these are just some introductions of the different data types in R that are the most fundamental concepts in R programming. So you pretty much deal with the different types every day using R programming. Okay, so and of course a scala is simply a vector of length 1. Okay, so now we started to actually work with the different objects in R. Okay, I hope these R installation and the problems will be resolved. And if it is okay for you guys, if you're not able to install R today, but for tomorrow we'll have more. I hope to get more involved in the hands-on part. So I hope that we can resolve the R installation issue by tomorrow. For example, if you Scala is just a number or any kind, or just a single value. Now I am assigning 2 to a variable called x. And when I type x again, okay, so how should I do that? Yeah, okay, this is better. So now I copy and paste this into my R console. It will say, so this line is telling me I'm assigning a value 2 to x, and if I type x, it will output the value of x. And this is assigning a value 3 to a variable called a. And when I look at, and this is telling what is the property of a. Okay, str is outputting the property of this variable called a, and it is saying, oh, a is a numeric variable called, and it has a value of 3. See, class is another way of telling you more or a simpler summary of the characteristics of the variable a. So it's telling me, oh, this is the numeric variable. And if I wanted to make a vector out of it, so a vector, you just you use a C to concatenate the two values into it. But I'll show you more on vectors in the next section. But now you have so now you have assigned values to different you have assigned values to different variables in your working space, and you can see now my working space consists of 4 variables now, and you can check on what are they. A is a vector called 3 and 4. X is a scalar of 2. A is a scalar of 1, and I don't know what a DAT is. DAT. Okay. So now I can make all kinds of operations using the variables that I have specified in my data. For example, now I'm assigning log of 10 to y. So now I have value of x and y. I can add the two. So like Dr. Chi Zhang has mentioned, you can simply treat R as a super calculator. Yeah. So I'm calculating what is the value of adding x and y together. And you can also do more scientific calculations. So what is the value? What is it to add an x and a power of y to the power of 2 together, and it will immediately give you this value in here. Okay, so these are scalars, and how do we operate with the different scalars? And to create a vector of numbers, use the C function. Okay, so C is short for concatenate. So now I'm creating my vector, copy and paste this into my command, and my vector is now a vector of length 5, consisting of 5 integers. And if I know that I want to create a sequence from 1 to 100 or from 0 to 10, instead of writing 1 to 100, I can simply use a colon function, a colon, to make a sequence from 0 to 10. Okay, so this will give you a sequence of 0 to 10. And if you want to say, I want to create a sequence from 1 to 100 with a step size of 2, then how would you do that? So then I will say seq 1 to 100. I hope I'm right. So this will give me a sequence from 1 to 1000. I typed in 1000, and with a step size of 2. Okay. And you can also create a vector of repetitive numbers. For example, this is a vector of a repetitive sequence of 1, 2, 3. So use this function called rep. So this is saying that I'm going to replicate a vector called 1, 2, 3 for 8 times to create this repetitive sequence. Okay. And in order to reference the numbers or reference the elements in a sequence, then for a vector, you can use this brackets, square brackets, to reference the elements in it. For example, I want to see what is the first number in my sequence. It's called 1. And what is the 100 number in my sequence? Is 199. So this is how you wanted to reference numbers. You can also reference multiple numbers by using the C function. So I can reference a vector of entries in my sequence. Okay. For example, I want to see what is the first 100th and the 200th elements in my sequence. It will give me the values in the corresponding position. Okay. Yeah, and also if I wanted to create a sequence that does not have the third value, I wanted to remove the third entries in my sequence, then I just put a minus in front of 3. So let me create my sequence again. My sequence. Okay. Yeah, now my sequence is from 0 to 10. And if I remove the third one, it will have, the 2 will be missing from this new sequence. Okay. Yeah. And you can definitely assign new values to the sequence. Now my sequence is the first position is called 0, second 1, and so on. But if I wanted to change the values in this sequence, I can do this. So this is saying that for the first and the third position in my sequence, I want to change the first one to 22 and the third one to 60. So now you can see that instead of being 0 in here, the first value is changed to 22 and the third value is changed to 60. Okay, so this is how you deal with vectors. And for matrices, you need to specify how many rows and how many columns that you should have in your matrix. Okay, so this command creates a matrix of 3 rows and 3 columns, and the values of it is from 1 to 9. So so you can see that the first 3 numbers becomes the first column, and the second 3 numbers becomes the second number, and the third 3 numbers becomes the third column into it. Okay, and how do you reference values in a matrix? It is also using the brackets, but now in a vector you have only 1 dimension, so you can reference it using only 1 number. But in a matrix, because you have 2 dimensions, then you need 2 indices to reference a certain value in it. So to see the second row, second column, what is the value for the second row and the second column in the matrix, I'm referencing it with the second row 2, second column 2 in here, which should be 5. Okay, and to reference an entire row in my matrix, I can just not specify the column indices by saying, oh, I want all the columns in the third row, which would be the third row, the entire vector in the third row. And if I wanted to reference the third column, then I can just ignore the row indices and use only the column indices. This is saying that I want the entire column for the entire column for the third column. Okay, regardless of which row it is in. Okay, everything in the third column. And you can certainly build up a matrix using from the vectors that you have specified. For example, now you have here, I have created 3 vectors, V2, V1, V2, and V3. And I can create a matrix out from the 3 vectors by using Cbind. Okay. Cbind is a command that bind the vectors in a column fashion. Okay, as you can see. So you can see that the first column becomes the first vector, second column becomes the second vector, and the third column in the data mat becomes the third column. What if I do a row? What if I do a row bind? It will bind the vectors in a row fashion. So the first row will be the first vector, second row, and the third row becomes the second vector and the third vector in here. So Cbind, and the Cbind are 3 very, very useful functions that are built in R for you to create vectors and stuff. So sometimes if you wanted to record, for example, the students' grades or your own grades or your monthly expenditure, then you can use C or Rbind or Cbind to store them in your R working space. And then next time if you want to visualize your data or you want to make certain operations in your data, then you can use the saved data. And for a list, it is much simpler. So you can pretty much put anything. You can pretty much put any. Okay, so you can put pretty much anything into a list. For example, the first value, the first element in the list is a numeric value, and the second one is a string vector, and the third one is a matrix that we have defined, and the fourth one is a vector, I believe. Oh, is a scalar. Okay, so now this is how a list looks like. So all the elements in this list have different length. They have different data types. Okay, so this is showing you that the function list has less of a structure than a matrix or a vector, but it is more compatible for you to store quite a heterogeneous types of data. Okay, I think I'm going to stop it from here. Okay, I think I should, before I stop, I want to also mention how do you reference the elements in the list. You can also use a bracket or a double bracket. So the difference between a single layer bracket and a double bracket is that for this one, after you reference it, it is still a list. But for the double brackets, after you reference it, it becomes a numeric vector. So you can check the class, you can check their types, right? See, if I use a single bracket, it is still a list. And if I use a double bracket, it becomes a numeric. So I'm going to stop it from here. And okay, so I hope that you guys are all able to access the tutorial in either the HTML file, the format, or the PDF format. And the next, we will get more involved in hands-on training tomorrow for the next session. So I hope that if you have any problems installing R or RStudio, please let us know. Thank you.
Thank you so much, Dr. Kyle. Students, there's the reactions button there. Let's give her a nice round of applause. There we go. Appreciate it.
Thank you, guys.
See everybody tomorrow. Bye-bye. Same link.